Happy learning. In the today's session, we are going to see about guided media. This is Mrs. E. Ponmalar, Associate Professor of Computer Science, the Standard Fireworks, Rajaratnam College for Women, Sivagasi. The topic guided media comes under computer networks. So, what is a computer network first of all? Network, actually we are going to have a connection of computers. So, network of networks. So, the computers, when they are going to communicate, we need a sender and a receiver, and the sender is going to perform the transmission and the receiver is going to perform the receiving of data. And the information that we are going to transfer is going to be passed through a medium. And what are the different medias we are going to see regarding guided media, and then the conclusion. So, when we want to transfer information, the transmission medium can be a physical media. So, if it is a computer network, we have two layers. One at the receiving end we will be having the physical layer, and at the transmission end also we will be having the physical layer. So, in between these two devices we are going to transfer the information, and that information can be transferred by means of two type of media. Number one, guided media and unguided media. So, guided media, what is meant by guided media? The information is going to pass through a channel. So, it is going to be bounded, and this bounding information can be in the form of a twisted pair cable or coaxial cable or fiber optic cable. So, through these three different guided media we are going to transfer the information, and in the today's session we are going to see about these three guided media products. So, if we consider the information is going to be transferred, there is a limit in the transmission mode. So, when we consider the first method of using the twisted pair cable, we have two conductors and they will be made up of copper, and each will be having its own insulation. The insulation normally will be a bad conductor, and both the cables will be having these conductors twisted together, and so that the interference of the electricity is minimized or mostly nil. And in this twisted pair cable we will be having one wire which carries the signal to the receiver, another one will be the ground, similar to a positive and negative when you send the electrical signals. So, the receiver, what will the receiver do? The receiver will find the difference between the two levels from wire 1 and wire 2 and remove the unwanted signals, and the receiver will find out the difference between these unwanted signals, and when they are connected in parallel the effects will be in such a way that it will make it as 0, and if there is a difference then the balance will be transmitted, so that we have the twisted pair cable. So, now in the twisted pair cable, the twists actually in between the particular distance, what is the unit of length over which the twists are there? It is going to determine the quality of the cable. And what will happen if I have more twists? More twists means better quality. Example, in the telephone system and Ethernet cable we use the twisted pair cables, and we need to transmit in between more longer distances. The receiver and the transmitter, they are present at a longer distance far away, then in between we need a repeater, so that the repeater will again make that information multiplied and sent, so that it is not lost and the performance is better at minimum cost. And these cables, actually we have unshielded and shielded cables. The twisted pair cables, they can be shielded or unshielded. So, in the shielded, naturally we will be having a shield in between, as shown in the figure you can easily identify. And the unshielded twisted pair we call it as UTP, and the shielded pair we call it as STP. And when we consider the connectors, which are going to connect the devices, we need the UTP connector, and the most common of UTP connector is the RJ45 jack. So, the expansion of the jack or J, mostly we forget, is registered jack, and this is needed for communication. And what about the performance? The performance of these cables, we are going to identify the attenuation and the frequency and the distance at which it is being received, and we have a gauge which measures the thickness of the wire, and if the thickness is more, the conductivity will be more. And coming to the applications of twisted pair cable, it is used in telephone lines, the UTPs, and DSL lines, digital signal lines, we use also the UTP, and the local area networks. In the labs, we use this UTP cable. And now coming to the second part, coaxial cable. Coaxial, from the name itself we can have understanding that we have an axis and we have same axis for more than one carrier. So, if you consider the central part, we will be having a wire, and after that we will be having a conductor which is going to be a stranded wire, and it can be either solid, and we will be having another insulation and then another metal wrapping, again another insulation. This is the concept of a coaxial cable. So, the outermost cable, if we consider, it will be a plastic cover, and in between we have the sheath which is the real conductor. And the coaxial cable standards are being set by the government, and it is called a radio government ratings, RG, and each RG number identifies the physical specification of the coaxial cable standards. And for cable TVs we use the RG 59, and the thin internet 58, and thick internet we use RG 11, and the impedance is actually 75 and then 50 and 50 ohms respectively. And when you consider the coaxial cable, the connector that we can have, another option is BNC cable, and for this actually we have a coaxial cable and another T connector we will be having. So, the figure represents how we can have the BNC cable connected, and nowadays they have become outdated. And now coming to the application, it is used in analog and digital networks, telephone networks, and then we have cable TV networks and traditional Ethernet LAN. Now, these twisted cables and coaxial cables are now becoming outdated, and they are being replaced by fiber optic cables. Now, coming to the fiber optic cables, it is made up of glass or plastic, and it transmits the signal in the form of light rays. And what is the principle behind this fiber optics cable is, we have a light ray, and when the light rays passes, it is going to enter at one end and it is going to come out at the other end, and the light rays are going to be reflecting on meeting the surface, and it changes the direction, and here based on the reflection it is going to be sent through as a channel, and it will reach the receiving end, and the signal loss is very minimum. So, nowadays we can say approximately it is lossless. So, we go for fiber optics cable. So, fiber optics cable actually we have a glass or plastic core, and which is surrounded by the cladding. Cladding means cover, so that we have a minimum loss or zero loss. Now, coming to the propagation modes, how the wave is going to be sent, the light waves are going to be sent is through a single mode or multi-mode. We know single mode means as a single ray, and a dual mode we are going to have multi-mode, and in multi-mode actually we have two types, one is step index and then graded index. And the fiber optic connections actually we can have it in different ways. How the connector is present? We have the AC connector, and this AC connector is the subscriber channel connector which is normally used in cable TVs, and we have the straight tip connector called as ST in short, and we have the RJ connector, and now this MT RJ connector is also being used for as a new connector when compared with RJ 45. And the applications of fiber optics cable actually, it's now true, yes, backbone of the entire networks has now become fiber optic cables. And for cable TVs also, nowadays the coaxial cable is replaced by the fiber optics, or they are using for lossless transmission fiber optic cables as a hybrid network where we will have combination of both. So as a conclusion, we can see which one is the best. Fiber optics cable is the best. So why? The reason is we have higher bandwidth and we have less signal attenuation or loss, and when you connect the fiber optics cable, we can go up to 50 kilometers, whereas for a cable, if we are going to go for lossless, for 5 kilometers only we can use, when compared with the coaxial and the twisted pair cables, only 5 kilometers is the distance, whereas fiber optics we can go for 50 kilometers, and if needed we can have repeaters, and the signal that you are going to send is immunized. How? For a human body we have immunity, whereas here in electromagnetic noise channel it won't affect the fiber optics cable. That is the immunity given by fiber optics. And if we consider the material that you are going to have, metals, you are going to have a fiber cable, and normally we have the corrosiveness. If I am having an iron, then it may get corroded by water, whereas here we use glass. So glass is actually having more resistance and it is anti-corrosive in nature, and hence it is better, and the weight also is light and more immune to tapping. This is a very important point. In case of cable TVs, you might have seen cable connection has been given to or allotted to one house, and the person who is living in that house may tap by connecting a wire, and that wire can be connected to a television where it is connected to another person's house. Like that it may be misused. One person may pay for it and 5 or 10 persons may be using the cable connection. Now this can be avoided, because fiber optic cables we cannot tap it whatever we want. We want specific connectors. So if you are going to use a fiber optic cable, it's very better. Now is it really better? Yes, it's better, but some drawbacks are there. The drawbacks, which is only minimum, because fiber optics cable installation is not very easy and it cannot be done by a person, a layman. We need a person with expertise who can install the fiber optics cable. And another method is the information that we are going to send is unidirectional, and it can be from transmitter to the receiver, vice versa cannot be performed, and in that case we need two cables, one fiber cable from one transmitter to the receiver, and the receiver side also needs to transmit information. We need another fiber optic cable. In that way, if we want specifically bidirectional, we have to go for two fiber optic cables, one from, for example, left to right, another one from right to left. So the cables and interfaces, they are also costly. So we conclude that the fiber optic cables are the best with minimum drawbacks. So we will meet once again in our next session. Until then, bye bye. Thank you.